Hello everybody and welcome to 10.6 day 2. So what we're going to be looking at today is a system of forces acting on an object, which is a common application of vectors. It's an idea in physics, so if you've taken physics this year you may have used some ideas like this. So some important things to remember are that every force has direction and magnitude. Much like Vector the villain would say, I commit crimes with both direction and magnitude. Oh yeah, oh yeah. You can just imagine me doing the dance that he does in that video, just to give yourself a little bit of a laugh. So what we're going to be looking at today too is remembering resultant forces, and that means we basically are adding together forces that are in the same system together, that are being used together. And this graph here kind of shows you how we're adding those together. So if we have this vector v and this vector u acting together on some object, which could be at the origin there, the resultant force, or the one force that is pulling that object or pushing that object, is going to be this middle vector right here. So we would just have to find the magnitude, add those two vectors together, and find the magnitude of this middle vector to get the force of that. Okay. So what we're going to be looking at is two types of problems like this. We're going to be looking at two forces acting on an object, which is what this graph is showing. And then we are also going to be looking at a force on an incline. And this might be something more that you've looked at in physics, a force on an incline. All right, so let's just get started. Suppose you and your friend are standing with a 35-degree angle in between the two of you. So I'm just going to kind of write in on this picture here. Here is your 35-degree angle between you and your friend. And you're pulling a wagon. Each of you has a length of rope. You are pulling with a force of 200 pounds. So let's say this is you here. You're pulling this one here. Right? That's you with a force of 200 pounds. And then your friend is pulling 35 degrees away from you with a force of 150 pounds. So you're obviously stronger than your friend. Good for you. First, what you're going to want to do is find the components of these two vectors. So what you're going to be imagining here is you are imagining that these are on a coordinate plane here. So you have your y-axis and your x-axis here. Let's say you are the one pulling along the x-axis. So that vector is pretty straightforward to find. So your vector is just the horizontal length, which is 200, right? And then the vertical, which is 0, because you're just pulling straight out from the origin. So your vector is 200, 0. But then we have to find the components of your friend's vector over here in blue. Okay, your friend is pulling in a different at a different angle, right? So remember, we have to use to find the components of a vector. If you know the magnitude, remember we have to find the components of that vector. So we learned yesterday that the first component is going to be the magnitude, which in this case is 150 times cosine of the angle. So this is from the other day's notes. And then to get component B, you do the magnitude 150 times sine of that angle that the vector is, of that direction angle. All right, now we need to get the resultant force of these two vectors, because we're trying to figure out, okay, if we add those two together, what is that force going out this direction, right? So essentially we're adding that vector and that vector together to get this resultant force here. We're going to call that RF for resultant force. So our resultant force is just adding those two together. So we're going to add the two A components. So 200 plus 150 cosine of 35 degrees. And then to get the second component, we're going to do 0 plus 150 sine 35, which is just going to be 150 sine 35 degrees. Okay, you can simplify those by plugging those into your calculator, but what we're going to do next then is finding the magnitude of that vector, because we need to find this single force here. And remember, length and force, magnitude are all synonymous vocabulary terms. So for part 3, we're going to find the magnitude of that resultant force vector, which is, remember, the square root of a squared. So 200 plus 150 cosine 35 squared plus b squared, 150 sine 35 squared. Okay, so now what you're going to do is type that into your calculator. All right, and once you type that into your calculator, you should get 334.14 if you round. And now this has a meaning now. We're pulling with a force in terms of pounds. So this is 334.14 lbs or pounds. All right, so let me help you get set up on this one and then see if you can follow the 3 steps from the previous slide to continue with this. So to get this set up, you have 2 trucks pulling a car out of a ditch, an ice cream truck, it looks like, and a semi-truck. And I'm going to color code those. Color coding is very helpful in problems like this because you kind of got a lot going on. So an ice cream truck is going to pull with a force of 2,000 pounds. It doesn't matter which one you do on the x-axis. I just usually pick the first one. So I'm going to say the ice cream truck is pulling straight out from the origin with a force of 2,000 pounds. So the magnitude of that vector is 2,000. And then your semi-truck is pulling 8,000 pounds of force, 25 degrees away from the other one. So about 25 degrees up in this direction. And if you want to sketch it to scale, make it look a little longer because now this one has 8,000 pounds of force that it's pulling with. So it's going to be longer than the other vector. And then we'll write in our angle, our 25 degrees, so you don't forget. And what we're trying to do is we're trying to find the resultant force. So you're going to try and combine those 2 vectors together and find that resultant force, which should be somewhere out in this direction. Okay. So go ahead and use the steps that we used before to see if you can figure this out. And then when you unpause and come back, the answer should be on your screen. All right, so as you can see here, in red and blue here, we found the vectors for each of these forces. Then we have to get the resultant force, which is the purple vector that I kind of sketched in there. And that we did by adding the A components together, 2,000 plus 8,000 cosine 25, and then the B components, 0 plus 8,000 sine of 25, which gives us 8,000 sine of 25. Then, to find the resultant force's actual force in pounds, we find the magnitude or the length of that force, and that is the square root of A squared plus B squared. And when you type that into your calculator, you should get 9,848.95 pounds. If you are getting decimals that are different or off in some way or another, make sure that your calculator is in degree mode. So hit that mode button and make sure when you scroll down, you see that degree is highlighted, not radians. All right, so the next type of problem we're going to look at, you may have seen in physics if you're taking a physics class or if you have in the past, and it's going to be an object sitting on a ramp and there'll be like a force acting on it, like trying to keep it in place or to push it. So what ends up happening is what we do is at point E here is where that object would be sitting, and then this vector right here would be the force of gravity. And then what we're going to do is try and essentially create similar triangles. So we think of another measurement or force acting in this direction, and that creates a right triangle right there. And then what ends up happening is since these 2 lines are parallel with each other, we get a bunch of similar or equal angles. So since we have a 90-degree angle and then another angle here that's the same, we can then say that this angle will have to match the other angle. that's over here. So this angle down here becomes theta. So we've created two similar triangles. And what I want you to do is basically what we're trying to say is that this length right here, so let's say, let's change our letters a little bit here. This is going to be E, and we'll call this D right here. So this will be D. So DE, we're trying to say, is actually going to be the same force as, and we're going to change this one to F. We're trying to say that this DE right here is actually going to be the same force as AB. So we're trying to prove that the magnitude of V, this vector AB, is going to be the same as essentially this measurement of gravity. All right. So what I want you to do is see if you can set up a proportion to show that the magnitude of V equals G. So it's been a while since we've done geometry and similar triangles. So what we're trying to do is set up a proportion of similar sides. So how we end up doing this is you're going to want to look at, for example, we're trying to compare short side to short side, so those corresponding sides, and then long side to long side as corresponding sides. So basically this short leg, DE, is going to be proportional to CB because we have to do corresponding angles as well. So I had to go from 90-degree angle from 90-degree angle. All right, and then we're going to compare the two hypotenusi, however you say it. And that's going to be EF over BA. Okay. So as you can see, all right, let's look at our labels. So DE, we are saying should be the same force as the magnitude of V. So I'm going to do that over here. So magnitude of V over CB, which is your gravity vector, right? Because that's going to have the same force, BC and EF. And then we're going to say that EF is G, and then BA is the magnitude of V. So as you can see how this is set up, if you were to, you can basically see then that corresponding parts are going to have to be equal to each other in order for this to work. So the magnitude of V is interchangeable with your force of gravity. So what that tells you then is that if we can find, let me do this in a different color. If we can find this length right here using our gravity force and our angle, then we found the force that's acting upon this object that's sitting on the ramp. So that helps us then get into this next example. We are saying that a 200-pound box lies on a ramp at an angle of 24 degrees. So this force down there, going down in this direction, is 200 pounds. Okay, the weight of an object is its force against gravity, or force of gravity. So 200 pounds. Makes a 24-degree angle. Now remember, we created this kind of similar triangle right here, so that this angle right here is going to be the same as this angle. So this angle right here is also going to be 24 degrees. A rope is tied to this box, so there's a force acting on that rope. We are ignoring friction just for simplicity's sake. I know in physics, you might have to take that into account a little more. But ignoring friction, how much force is being exerted on the rope by the box? So what is essentially this vector right here? So we're trying to find this force. Those similar triangles then told us that the magnitude of this side will tell us that force right there. Okay, so in order to do that, we have this right triangle. I'm going to kind of sketch it out so you can maybe see it a little better. And we're trying to find this missing side right there, that magnitude of V. So this is just a right triangle, and we can just use some trigonometry to help solve that right triangle. So if we look, the angle we have is 24 degrees. We have what appears to be the opposite side and the hypotenuse. So we're comparing opposite and hypotenuse, so we're going to use sine. So sine of 24 degrees equals opposite over hypotenuse. So to solve for the magnitude of V, we're just going to multiply the sine of 24 by 200. And then making sure your calculator is in degree mode, 200 times sine of 24. You get that then that box is acting on that rope or pulling on that rope with a force of 81.35 pounds. Okay. So going on to this next example, I'll help you set it up. So we are looking at a 200-pound cart. So your cart is sitting right here. So 200 pounds is acting down that way. So we're going to say the magnitude of this vector going down is 200. Suppose Sam, here's Sam, is using a force of 100 pounds to keep the cart from moving. So this force right here acting in this direction is 100 pounds. Now, because of similar triangles, that means just from here to here, we can also say is 100 pounds. That's going to have the same force. What is the angle of the ramp? So we're trying to find this angle right down here. So using the same idea, now we're just solving for the missing angle. So use what you know about trig to see if you can set this up. So pause here and see if you can set it up and solve for the angle. All right, so hopefully use sine. So sine of theta is going to be your opposite side over your hypotenuse. We know that's the hypotenuse because it's across from the 90-degree angle. And you get sine of theta equals 100 pounds over 200 pounds, which is equivalent to 1/2. So you're solving sine of theta equals 1/2. I know we kind of have a lot going on here, but I hope you recognized that 1/2 is a sine is 1/2 in some parts of the unit circle. Right? So if we look at our unit circle, sine is 1/2 at 30 degrees. It would also work to use your calculator, solving for theta by doing sine inverse of 1/2. And if you type that into your calculator, you should see that you also get 30 degrees doing that. Okay, but if possible, if you recognize a value that you know should be on the unit circle, you can always use that to help you continue. All right, last problem here. This is more similar to the first one we did with the box sitting on the incline. So what I'd like you to do is see if you can set this one up, label your picture. You will have to draw in your extra, gravity vector with your similar triangle. But see if you can set this one up. Hit pause, and then when you're ready, hit play to walk through the problem. So this one is set up a little bit differently. So a force of 567 pounds is required to pull a boat and trailer up a ramp inclined at 12 degrees. So now our force is starting right here. It's not a gravity force because now you're asked to find what this vertical vector would be, this force that the weight of the boat is pushing down on gravity at. Okay, so your triangle should look something like this, 576 pounds for this. Then we need to find this length, the hypotenuse length, in order to find the weight of the boat and trailer, because that's the weight that's pushing down on that ramp. Okay, so again, we're going to use sine. So sine of 12 degrees equals opposite, 576 pounds over the magnitude of that gravity vector there. So to solve this one, basically you would cross multiply, but what ends up happening is you just kind of flip-flop the sign and the magnitude. So the magnitude of that vector is going to be 576 divided by sine of 12. Make sure your calculator's in degree mode. Type that in. Whoops. 576 divided by sine 12. And you get 2,770.4 0.41 pounds. So that weight of that trailer and boat should be 2,770.4 pounds. And hopefully, you know, as you're doing these, you're kind of checking to make sure whether or not your answers make sense. That should about do it. So those were our three or four different types of force problems. So take a look at the worksheet. You might need some more practice with these. So try a few of those, maybe find one of each kind and give it a try. And then try that daily task on Schoology.